Hello guys, and welcome back to Joe's Ventures. And today we're doing part 99, penultimate, for our Jurassic World Evolution 2 mod spotlights. We'll be taking a look at some of the wonderful mods people are making and use them to talk about some of the fossils and compare them to the real life fossil counterparts. Got my intros confused. Anyway, same kind of thing. So this is penultimate to 100. But we've still got some really cool species today. I'm actually quite excited because we've got a lot of Paleozoic species. Those always deserve some love. The Paleozoic is a very underrated time in Earth's history. I think it deserves a lot more attention because it's just so wacky and weird. But yeah, we've got some Paleozoic animals today. We've also got a few dinosaurs and mammals as well, so almost got something a little bit for everyone, which is quite cool. But we're going to be starting today with everyone's favourite giant ancient millipede, done in the myropod. We have got Arthropleura, done by JWE2 as part of the Paleozoic Animal Pack. So this is Arthropleura. Really, really beautiful guy. So let's see if we can pick one. Who should we talk about? Which one? We'll have a look at you, because you are in a nice pattern. And this is the pattern from Walking with Monsters. So Arthropleura, which is ancient Greek for anthron, would mean joint, and pleura means rib, so basically a name means joint rib. These guys are an extinct genus of massive myropod that lived in what is now Europe and North America about 344 to 292 million years ago, throughout the lower Carboniferous right up to the beginning of the Permian period. So they are a type of millipede, since they are herbivores, and was capable of reaching at least 2 meters, or about just over 6 feet 7 inches, and possibly over 2.5 meters, 8 feet long, making it the largest known arthropod of all time. And it's known from body fossils as well as trace fossils, with giant trace fossils up to 50 centimeters wide, or 20 inches wide, and also large burrows, which is quite cool. So we'll get into its kind of first discovery. So it was first discovered in 1849 during construction of a railway in Germany, and it was very much, not complete. So it was almost like, what the heck is going on here? But prior to them, it was actually distributed to a crustacean, Arthropleura armata, which is a larger crustacean, seemed to be related to decapods as well. But then it was actually found, they were also compared to trilobites and riptorids. And then another specimen was found not too long later, and found that it was actually more likely an arthropod, arachnid insectum arthropod, a non-decapod crustacean, and then was compared to isopods. And then in 1934, there was a landmark study that actually kind of found it to be similar to trilobites in that regard, and they also suggested they were carnivorous as well. And we didn't know much about the heads, but we'll get into the heads a little bit too soon. So this is typically kind of how they figured out they were actually, different types of. They were actually a millipede, not a trilobite or anything like that. So that's quite interesting. And they actually suggested originally that there were curved structures found along the edge of the head that would look like mandibles they used to kill prey, feeding on things like that. And they also believed potentially that Arthropleura was amphibious, living on lake beds and things like that, which is quite interesting as well. But this seems to be a taphonomic artifact, and that actually, we'll get into their ecology thing before, but they seem to be herbivorous. So Arthropleura as a myropod, or relative of myropods, or probably diplopods, they have been the prevailing view among scientists in the following decades, and their limbs have actually become quite well understood. So there's quite a few species described in quite a few specimens, so we do have a pretty good idea what Arthropleura is like. So there have been many found in Nova Scotia as well, and Ohio, Pennsylvania, and Scotland. However, the head segment was kind of erratic for the next century or so, and they also had the Devonian millipede microcephalix kind of become a part of Arthropleura, and they used that to copy the head. But turns out in 2024, there was some exceptionally preserved fossils of juvenile Arthropleura that showed that its head, the head identified by past authors was indeed the head, and it looks like a car bumper, and there's two external mandibles, an internal set of mandibles, a maxillae, and then the mandibles inside. That's quite cool. So we know what they look like now. So in terms of morphology, multiple partial specimens and trackways suggest that Arthropleura could get well over 2 meters. Trackways of Arthropleura can be found in Nova Scotia that are about 50 centimeters, and even in 2021, there was a shed exoskeleton of an Arthropleura that was estimated to have a width of 55 centimeters and a length of 1.9 to 2.6 meters, so between 6 foot 3 inches and 8 feet 8 inches, and a body mass about 50 kilograms. And it is one of the largest arthropods ever known, and as large as Eurypterid Jaekelopterus, which we'll get into actually, or Jaekelopterus. An estimated length of 2.3 to 2.5 meters or 7-8 feet long. And the 2024 study that showed that juvenile head showed that they have previous unknown features. They had flattened ventral slericals and a pair of antennae with at least 7 antennal articles in front of the head. And they actually had 3 lobes on their head, kind of like a trilobite, with the juvenile having probably about fewer segments and stuff like that. So a very interesting face they've got going on there. Almost, look like they almost look like a really, really long Slater. That's probably the best way I could describe it. Arthropleura had 2 pair of maxillae and the 3 segments as well, with a morphology similar to a centipede, but they were definitely herbivores. And unlike any living myropods, they had stalked compound eyes. So that potentially, that could have been derived tape evolved independently from other stem myropods. So that's quite cool as well. And along each walking leg pair, there are among 3 pairs of ventral plates along the side there, and there's big K plates, B plates, and rosette plates. And the B and K plates are thought to be potentially for respiration, dealing with a larger size and allows them to kind of breathe better since they're using that hemolymph and stuff very similar to other insects and the spiracle. And things like that. So they're really trying to figure out how they could breathe as well. And the different species of Arthropleura are typically differentiated by dorsal ornamentation of the tergals. So that's kind of how the different species are. But because their complete species are rare, specimens are rare, they're typically they're poorly delineated and could potentially show different growth stages rather than different species, so it's kind of hard to tell. So a lot of species could be potentially just smaller ones as well, but we know they got quite big. So most fossils of Arthropleura are actually thought to have been molted shells, and they're typically reconstructed living in coal swamps based on the co-occurrence of fossils there. However, that's no longer strictly supported, as many fossils of Arthropleura are found either before or after the domination of those coral forests, or direct geological and paleobiological evidence suggests that its primary habitat was actually far more open, which is interesting as well. So it lived along floodplains and coastlines, things like that. It's also found in association with tetrapod trackways, suggesting they lived in the same environments. In addition to these large trackways, enormous burrows have been found and have been attributed to these guys as they estivate or, kind of hibernate or brumate during the winter, which is quite interesting as well. And they are found in the Carnivorous and Permian as well, and quite near the equator. So Arthropleura has also been reported to potentially be amphibious to some degree. Despite it falling out of favour many years ago, it actually has been bolstered by new evidence, as they are found often on coastlines. It is capable of walking in air and shallow water, apparently. And the juvenile fossils have stalked eyes, unlike any other living myropod. And however, the likely stem myropod group that has the other stalked eyes potentially had in a semi-amphibious lifestyle, so that could work with these guys. And there's also potential that because of their large size, molting, and things like that, they could have gone to the water as their exoskeleton hardened, for protection. And so essentially and it actually has been suggested favoured far more terrestrial habits, as there's no obvious way to kind of breathe underwater, but they may have moved in a worm-like fashion using their softened legs to get hardened. That's kind of shown how they would do it anyway, to molt. In terms of their diet, it has been heavily debated. It was originally suggested to be a carnivore, but one has actually had preserved gut contents of a mixture of woody plants, so it's believed to be a herbivore. This interpretation based on these is no longer supported, though, and then currently it's believed to be a detritivore, like most extant millipedes, so feeding either dead or decaying plant matter or animal remains when available. They have short, closely packed legs. This was evidence from morphology in ichnofossil trackways, suggest they were a very slow-moving animal, and they didn't have the venom forciples and other predatory adaptations like modern centipedes do. So they're definitely a herbivore or detritivore, so something like that. The giant size of Arthropleura was frequently attributed to the higher oxygen levels of the carnivorous, but however, this actually does not align with what's actually the case. Arthropleura actually reached giant sizes before the rise of large of oxygen concentration in the Carboniferous, with the largest known body fossils found at interval with oxygen levels were only about 23% higher than modern day, and most likely they were capable of gigantism due to other generally favorable environmental conditions, ecological conditions, and a severe lack of competition. So there wasn't really many big animals like today. You know, if you get much bigger than a centipede now, you've got to compete with small mammals and small reptiles. There was literally no land tetrapods at the time, so they could become they could become the elephants of their time, the big animals that eat a lot of food. And consequently, they actually went extinct during the early Permian, potentially due to desertification of the equatorial regions and then competition with Permian tetrapods, and that could have drawn them to extinction. Be another really cool species, and I love these cosmetics. This one's the Life on Our Planet one, and this one's from Walking with Dinosaurs. Be another really cool one there. So we'll let them run off and do their thing, of course. Next up, if you guys remember Primeval, you'll remember this one. So this is Geralinura Britannica, and I just want to wait for you guys to get out of my way so I can release them. So this is Geralinura Britannica. There's a really cool guy here. We'll let them run out a bit so we can get their There we are. So here we are, and it's moving again. I hate it when it does that. So these are Geralinura Lunura. These guys are in the family Theropolidae. So these guys are just prehistoric whip scorpions, which is interesting. So that's literally kind of what they are. Fossil evidence is found in the Midwestern US and the United Kingdom, suggests this genus lived during the middle to late Carboniferous period. But unlike the subchelicerate pedipalps of modern whip scorpions, these guys had spiked ones, and they were non-chelicerate, suggesting that they were bonding traits that evolved later in a later point in time in the lineage of whip scorpions. So there is quite a few species described. Britannica, I believe, is one of the older ones. It was described by Pocock in 1911. And it is from, I believe, the early Pennsylvanian. Early Pennsylvanian. Not one of the bigger ones, but is on kind of the larger side, but not like one of the most massive ones. Yeah, really, really cool species as well. So this is when you see Primeval and that big scorpion, this is what they talk about. Even though it was nowhere near this big in real life, but they had to, exaggerate it because, that's what Hollywood and, TV's like. But anyway, we'll let them run off and do their thing. I'm just going to quickly close down the park. So next up, we are going over to the aviaries, so we can have a look at the rest of the pack. We've got a really cool species here. This one is Coelurosauravus. If you also remember Primeval, you'll probably remember this one. So even though it's not very accurate to the Primeval one, this is accurate to a real life Coelurosauravus. So let's have a look. Coelurosauravus. So let's have a look at this guy. So it's flying around, having a good time. No, that's not what we wanted. So let's carry on. It's not the one we wanted. Let's cycle them dinosaurs. I want to find one that's good colours. This one's alright. Where's my thing going? Weird. Here we are. It is a little bit small, but we'll have a look. What's up with my mouse recently? But here it is. So this is, let me just turn that off. Really, really cool. So this is Coelurosauravus, which means hollow-tailed lizard grandfather. So these guys are an extinct species of gliding reptile, even though they fly in the game, because they're banned in Jaekelopterus, known from the late Permian of Madagascar. And like other members of the group with Gelasauridae, members of the genus have long rod-like ossifications on their, projecting outwards from their body. They're not actually extensions of the ribs, but they're actually unique kind of bone spurs found only in this group. And it's believed that during life, these structures formed wings to provide, gliding flight, similar to living Draco lizards. And this guy is only found from one species, C. albanus, that was ascribed and named by Jean Provento in 1926, based on fossils of the lower Sacomedian Formation in Madagascar. And the species Utahceratops jackeri from Europe was originally considered a member of this genus, but now it's considered its own genus. So as I mentioned, it was collected in 1907 and 08 by J.M. Colbert, who was a French colonial infantry person in Madagascar that kind of found it. And in 1926, it was described as Coelurosauravus albanus, and in 1930 it was lumped as well. But then in 2015 they were considered split. So that's an interesting little history as well. And it has got a few specimens. They are actually pretty well known in that regard. In terms of description, they are the smallest of their group. They have a mature skull length of about 1.4 inches, about 3.5 centimeters, which is about half of the other Wagatasaurids. Their total combined head to body length was about 18 centimeters or 7.1 inches, and reached a length of at least 35 centimeters, 14 inches if you include the tail length as well. Like other Wagatasaurids, the skull bones had cranial ornamentation, and you can see kind of those tubercles there. It really gives them that dragon look. They have like a horn frill, and which is interesting as well. They have simple conical teeth that are packed in a dense row, and they seem to decrease posteriorly. And they, compared to other species or other Wagatasaurus, they have a shorter neck and longer thorax, which is also flattened. And like other Wagatasaurids, the penultimate phalanges are elongated, with curved things that potentially would have helped with climbing on tree bark as well. So that's kind of cool. Well, and when open, their wingspan would probably be about 35 centimeters or 14 inches as well. That's kind of how you get that kind of size there. But yeah, beautiful animal. Let's see if we can spot the other one. There's another one with better colours, I'm pretty sure. Let's move on. They're really small. It can be hard to find them. Cycle to the next one. So forth. That one looks fine. We'll have a look at this one. In terms of paleobiology, there have been no stomach contents found, but it has been interpreted as an arboreal kind of insectivore. So it would have been in the trees hunting for prey. And the simple conical teeth are actually well adapted for piercing the arthropod cunicle, and they believe that the cranial ornamentation or the frill it's got is potentially for display. And what's really cool as well, the rods orientate from the lower lateral surface of the body, and these kind of gliding membranes were controlled by abdominal muscles. And preserved fossils show that these bony rods had a high degree of flexibility, like the ribs of living Draco lizards. And due to the low wing configuration, it's likely the gliding surface was angled upwards to increase stability. Though in living gliding lizards found the forelimbs grab onto the membrane during flight. It's believed to be so similar to that for these Wagatasaurids. And it's suggested by the presence of the additional phalange in the fourth digit, they would have been able to more firmly grasp this wing. And a 2011 study comparing the other species of Wagatasaurids and other extinct gliding reptiles to modern Draco lizards suggests these guys would have been a less efficient glider to the modern Draco lizard due to its larger body size and wing loading that is much higher than the Draco. So they probably weren't quite as good gliders, but they could still do all right. They clearly lived for a while, so they did fine. In terms of their habitat, though, they lived in a paleo environment that was very much a wetland in the north-south Rift Valley, similar to Lake Tanganyika. Its climate at the time was kind of temperate, warm, with seasonal rainfall and even monsoons, and there were lots of interesting flora and fauna living with it, including the Parareptile Barosaurus and different types of Tendospondyls and the Rhapsids and Cynodonts. So it was quite a rich formation with all sorts of different cool Permian animals. So yeah, another really cool one there. So we'll let them go off and do their own thing. So next up we have got, we're going to the ocean for this one. This is our second to last one. This is Jaekelopterus, and they're really cool species, so let's have a look at these guys. This is another really beautiful one. Let's see if we can get a swim around a bit in the water. That's what I kind of want to see. Here we are. Looks nice to me. We'll have a look at this one. This one's got a cool posture. So this is Jaekelopterus. Or Jaekelopterus. These guys are a species of predatory, a predatory Eurypterid. So they're a group of ancient arthropods that are sometimes called sea scorpions. So fossils of this species have been found in the early Devonian age, and there's two different species. There's Rhinati, which is found in brackish and freshwater strata in the Rhineland, and Howley, which is found in Wyoming. And the name comes from the German paleontologist Otto Jaekel, who named this type species, and pteris, which means wing. So based on isolated remains of a large chelicera or claw from the clay formation in Germany, the first species, Rahanad, they actually believed to have reached a length of about 2.3 to 2.6 meters, or 7.5 to 8.5 inches, making it the largest arthropod potentially discovered, and surpassing other large arthropods like Pterygotus. And potentially Arthropleura is rivaled, so these two are kind of neck and neck for being the largest arthropod. So as I mentioned, they are known from quite large remains. The chelicera itself is about 36.4 centimeters long, but it's missing a quarter of its length, so it is quite big. And they are similar in overall morphology. They have a triangular telson that almost looks like a fluke. The pterygoids, they have a telson like that. They have large, claws to catch chelicerate or pincers to catch prey, very similar to modern species, and very typical anatomy of other Eurypterids, which I've covered before. And Howleri is actually known from much more specimens. They're much smaller, but it is more well known, so that kind of helps inform the different ones here. In terms of its research, it was really considered a species of Pterygotus until in 1914 by Otto Jaekel, who kind of described it and took a look at it. But based on more comprehensive material, it was actually described by Walter R. Grosch as its own genus. Charles D. Watson erected the genus Jaekelopterus in its, as that genus now, and he considered it significantly different from other Pterygotus species to consider it its own genera. So that's quite cool. And it was called Jaekelopterus was, one of the people that worked on it and described the original species. So I think that's cool that it got a name like that. And Stroma also put a new family in the house of the genus, Jaekelopteridae, which is interesting as well. As mentioned, the other species is not as well known. So it is, as mentioned, a type of pterygoid. So it is a Eurypterid, and it's related to Pterygotus and Coelurosauravus, which is other types of Pterygotus. And they believe to have got that potentially that way because of large size, and its relatives were quite large as well. So that's interesting how that could have happened. It is the largest of them all, but its relatives like Pterygotus and Echinomatus got both all around over 1.5 meters long. In terms of its gigantism, as I mentioned, it's believed to be one of the largest known Eurypterids, and several factors are thought to have contributed to its unprecedented large size due to predation, competition, courtship behavior, and environmental resources. And factors such as respiration, molting, and things like that can actually restrict the size of arthropods. Other than the robust and heavily sclerosed claws, most of the large body segments were thin and unmineralized, so they're actually considered paper thin, and thought to be quite lightweight. And similar lightweight adaptations have been observed, like in Arthropleura, and it's thought to be vital for their size. So they can still stay light, but still strong, so they have to be developed like that. Despite being the largest arthropod, they are quite lightweight, but they're also not the heaviest. There was the
Hybergatus, or Pteros, so we say that. There was a big 2-meter long Hybergatus, which was like a big species of Eurypterid that walked on land as well. And actually fossils actually suggesting that the size may actually be exaggerated and may have only been about 1.8 meters, so typical in size, but there's been controversy, and that's other specimens show that they could have potentially got that large as well. So it is pretty sure that they got to that size. And like many other species of arthropods, they do go through instars and then go through odiasis or molting, very similar to those species. And there's some evidence of that in these guys as well. There are several fossilized instars of Howleri, which is the smaller lesser known species known. It's difficult to tell that ontogeny through time. So they do grow, they kind of grow, very interesting as well. The denticles on their kind of chelicerae tend to, grow bigger as they get bigger. And the principal denticles grew in size relative to the intermediate denticles, so being about 1.5 larger, 5 times larger, the size of the intermediate denticles in juveniles, but up to 3 size of the intermediate denticles in adults. So these denticles were far more larger and more robust than adult specimens and juveniles. That's very interesting too as well. And the metastoma has altered in dimensions as the animal matured, as it kind of got broader in juveniles. So the metastoma in Howleri is broader in juveniles than adults, so they're kind of bulked up a bit. That's kind of what we know as well. In terms of its visual system, we know that these guys have different kind of separate ecological groups. They had compound eyes that they would have had high visual acuity with. So we do have fossilized compound eyes. So they had potentially visual acuity would have actually increased with age. The smaller specimens having worse eyesight. So the bigger they are, the bigger eyesight they had. And this is interpreted with adults living in darker environments or deeper water. And they do have a frontally overlapping visual field, so they did have stereoscopic vision that probably allowed them, and their eye structure is actually virtually identical to the eyes of horseshoe crabs, so that potentially would have been able to very much be able to chase prey and things like that, so they were quite well adapted for that. And the unique eyes of modern horseshoe crabs are highly distinct to those of other modern riptorids to increase edge perception and enhance contrasts, important for animals that live in low and scatter-like conditions. So these guys had very similar adaptations, and these highly specialized eyes suggest they were predatory, but also living in dark environments, so potentially like hunting at night and things like that. In terms of its morphology, these guys were completely adapted for living in the ocean. They were completely aquatic. As I mentioned, Eurypterids are sometimes considered sea scorpions. They're not closely related to scorpions. In most of the areas they have been found as brackish or fresh water, so they were definitely adapted for at least, living in the freshwater or estuarine brackish habitats, but they potentially would have lived out in the ocean. The chelicerae are quite large and robust. They would have been able to, have strong puncturing and grasping abilities like extant crustaceans and scorpions. So we do have puncture wounds in fossilized fish from the Devonian of Utah that could have likely caused by Howleri, the other species. And as I mentioned, they were active and visual predators. They would have done that to chase prey and pretty much would have eaten anything smaller than themselves. And they are quite a powerful and active predator. They were highly agile and highly maneuverable, and the hydrodynamics of the swimming patterns and talsons suggest they were capable of hovering, forward motion, and quick turns, so they would have been able to chase prey pretty effectively. But yeah, another really, really cool species that we get to talk about, thanks to Trip. Really, really cool. Could have made it a bit smaller, but it still looks amazing how it is. Actually amazing. So we're going to carry on. Next up, last but not least, for our Paleozoic pack, we have got Inostrancevia. So we finally got, something from the Permian that's a vertebrate this time. So let's have a look at this guy. Oh, wait, we've already got this. So there it is. Here we've got Inostrancevia. Let's have a look at you there. You look nice there.
Here we are. So this is Inostrancevia. So these guys are an extinct genus of large carnivorous therapsid that is found in the now late Permian of European Russia and southern Africa, so quite a wide range. The first known fossils of these guys were discovered in the context of excavations in 1899 to 1914 in northern Dvina in Russia. Among these are two near-complete skeletons embody the first described specimens of the genus. It became the first Gorgonopsian described in Russia. Several other fossils have been found there, with various finds leading to confusion on taxonomy, but I'm not going to get into taxonomy too much. But they actually found that could potentially be another genus. More recent research carried out in southern Africa from about, I think, just in the last couple of years actually describes these guys as an African genus. And the name of the genus as well honors Alexander Inostrancevia, professor of Vladimir Bialysky, the paleontologist who described the taxon. In terms of its skull, it had a body skull of about 40 to 60 centimeters, or about 16 to 24 inches, depending on the species, and a body length of about 3 to 3.5 meters. With Inostrancevia being the largest known Gorgonopsid, but only rivaled by the imposing Rubigenia. It has a broad and elongated skull with large oval-shaped temporal fenestrae and very large advanced canines, with canines up to about 15 centimeters long, or about 5.9 inches. So it's the first example of saber-tooth in the historical record. And like where been used to shear prey. And like other most Gorgonopsians as well, they had particularly large jaws, opening angles which allowed them to inflict fatal bites. And they were in general thought to be relatively fast predators in killing their prey by delivering slashing bites with their saber teeth. And they've also got quite a robust skeleton, but new studies are necessary for better understanding their anatomy as well. I'm not going to go through the Russian discoveries. It's still quite a big animal. Like today, it would have been about the size, of kind of like a grizzly bear. They've been estimated to be about at 350 kilograms, so still quite a big animal. Since its classification, it is in this Russian clade of Gorgonopsids related to Suchogorgon, for example. As I mentioned, there is also that African species. In terms of hunting strategy, it's thought to have been actually convergent with Smilodon as well, or maybe Smilodon would be convergent with this guy. These were kind of the first examples of saber-toothed predators, and they potentially would have grabbed prey and had a massive gape to kind of bite the neck and get the jugular and windpipe in one go and kill prey quickly. So it's thought to have killed very similar to saber-toothed cats and other saber-toothed animals throughout history. And also looking at its overall Gorgonopsian biology as well, they seem to have a lot of features they were a therapsid, so related to mammals, but they have a lot of features that were more similar to mammals. They were active predators. They had brains that were relatively smaller than mammals, and they had limited stereoscopic vision as well. They developed tubercles, a very advanced sense of smell, and they had these canines and teeth, so showing they were quite active animals as well. So they're kind of this halfway, but they were quite active, able to kill prey. So very much a big predator of their time. And also looking as well at their anatomy, they were far more upright and more primitive synapsid species. You can see this one kind of stands tall. They were very much, standing upright and not sprawling, so they would have been similar to the high walks and crocodilians, but more permanent as well. So they would have had more horizontal position and able to run around, more similar to like a tiger or something like that, which is quite cool. So in terms of what it lived with and what it was, it's the only formally recognized Gorgonopsian has a transcontinental distribution, as it's found in southern Africa and in Russia. And it would have been an apex predator of its time and would have lived with a lot of Dinosaurs and Pariasaurs, living with animals such as contemporary fauna. So it would have been areas that were semi-arid to arid, cold deserts with all sorts of different ancient species of plants, and even some areas that were a floodplain. Would have lived with animals such as Dinogorgon and Rubigenia, which was kind of competition. These guys would also live with Dicynodonts, Therocerodonts, Cynodonts. If you know Pariasaurus and Scutosaurus, which were quite famous for them. They also lived with Arthropleura such as Proterosuchus. other temnospondals, and reptilomorphs, so a very interesting assortment of animals living at the time. But these guys would have gone extinct at the end of the Permian, with the Great Dying, the biggest mass extinction that the Earth has ever seen, with about 70 to 90% of all life becoming extinct due to the Siberian traps erupting. So it was a huge eruption that took over 100,000 years and was pretty much the most devastating extinction in Earth's history. So another really cool species there. And, you know, this one's based on the Walking with Monsters 1 as well. So I do love these nice colours. Definitely did a great job. Really big fan of these Inostrancevia. So we're going to be moving on now. We're going to let them run off and do their thing. Definitely taking their sweet time. But next up, we are moving to some other species. These were all done by Trippy, who created the Paleozoic pack. You know, love to see some love for the Paleozoic species. But next up, we have got Utahceratops by Netraptor. Beautiful species, if I do say so myself, and that happens, of course. Raw. Let's have a look at these guys. There we are. Perfect. We'll have a look at you. Oh, no, that's not. What's technical difficulties today? Gotta be. Here we have got Utahceratops. So these guys are an extinct genus of ceratopsian that lived approximately about 76 to 75 million years ago during the late Cretaceous of Utah, hence the name. Not too dissimilar from other species of ceratopsians, you know, large, robust, ground-dwelling quadrupeds that could grow about 4.5 to 5 meters, between 15 to 16 feet long. The genus name Utahceratops come from, which means horned face of Utah. It's derived from, you know, Utah, the state of Utah, and then Greek for horn on the face. So basically, the horned face from Utah. And the specific name Getty describes the name of Mike Getty, who discovered the polytype and played a pivotal role in recovering this fossil. And it was described in 2010 by Scott DeSampson and a few other people as well. So the specimen itself, the holotype, is really only a partial skull, but it is known from 6 specimens, including 2 partial skulls, and taken together they represent about 96% of the skull and 70% of the postcranial. So these guys would have been about 4 to 5 meters long and about 2 tons in weight, so about the size, you know, kind of a rhino, maybe a little bit bigger, which is interesting as well. They are considered quite a basal ceratopsian, and are found to be quite closely related to, was believed to be, you know, Pentaceratops. Most recent relationships suggested it is related to Pentaceratops. And the only specimen known is from the Coelurosauravus formation, which is quite a rich formation. And argon dating, radiometric dating suggests these guys would have lived about 76 to 74 million years ago during the Campanian stage of the late Cretaceous. During this time, the site would have been, America was split by the Western Interior Seaway. So it would have been Laramidia on the western side, you know, along the Rocky Mountains, and Appalachia to the east. And these guys would have been living along that coast and floodplains of the the Rocky Mountains, which is quite cool. And we do have a lot of environment. It would have lived with animals that are probably quite famous to you. Tetraphonius, Troodontotalos, Parasaurolophus, Cryptocristatus, Nasutoceratops, Cosmoceratops, Albertosaurus, and Ornithomimus, along with a rich variety of snakes, sharks and rays, frogs, turtles, lizards, crocodilians, and mammals. So quite a rich environment with lots of cool things. But yeah, another cool Netraptor species. You know, Netraptor always killing it. So let's carry on with the next species. Next up, we have got Megacerops, so another mammal. You know, I love seeing mammals today. So let's have a look at these guys here. So this is Megacerops, and we'll have a look at the baby when we're done. So let's Megacerops. Release. There we are. Oh, look at that. Awesome. Let's have a look at you. I'll have a look at you since you've got the most accurate colours. So Megacerops, which means large horn face. These guys are an extinct genus of prehistoric odd-toed ungulate in the family Brontotheridae. So these guys would have been very much rhino-like browsers. And they were actually more closely related to horses than they are rhinos, but whatever. They are endemic or only found in North America during the late Eocene, between 38 to 33 million years ago, and lived for approximately 4 million years. So Megacerops was described by Liddy in 1870, and the type species is Megacerops coloradorensis. And if you know other species in the genera, you know, Brontotherium, Brontops, things like that. If you've ever heard of those kind of guys, they've all been lumped into this guy because the bone wars and all that. So if you've heard Brontotherium, this is Brontotherium. So all the species have a pair of blunt horns on their snouts, the size varying between species, with the horns of males being much longer than those of females, and it could indicate that they were butting heads and using them, to compete with each other. Despite resembling a rhino, though, they were quite large. They were larger than any living rhino, reaching about the same size of an African forest elephant, which is the third largest animal living today. They stood about 2.5 meters or 8 feet at the shoulder, an overall length of about 4.6 meters or 15 feet in length. The skull reached about 89.5 centimeters or 35 inches in total length, and some of them had some pretty big canines that were up to 70 millimeters in length. And they also had this large rhinoceros-like Y-shaped horn protruding from their nose, up to about 43 centimeters long, and the mass estimates put it between 3.3 to 3.8 tons, so still quite big. The dorsal vertebrae above the shoulders has extra long spines to support that huge and heavy skull with those muscles, to support the muscles to carry that skull. And the shape of the teeth suggests that it was adapted to eating soft stems and leaves rather than tough vegetation like grass, and may have had fleshy lips and a long tongue to carefully select these foods, kind of like tapirs, for example. That's probably a good example. So in terms of the paleobiology, skeletons of adult males have been found with partially healed rib fragments, so that suggests a theory that they would have used these horns, quote-unquote, to fight. And there was no other creature, really probably time that could inflict an injury like these guys, unless it was another Meropus, which as well. And the breathing movements actually prevented these fractions from healing. And the adults may have used these horns to defend themselves from predators and their calves, defends themselves and their calves from predators such as hyenodonts, entelodonts, Bathornis, and ravids as well. So, speaking of that, we'll have a look at the little baby, because I do love a little baby, because they're very, very cute. Let's have a look at these guys. Cute little calf. So here's the little calf. So we'll have a look at these guys while we get the chance. So these little guys, they're like their parents. Fossils have been uncovered in northern plain states. Life-size models of Megacerops families have been displayed in a few different places as well. Many remains have been found in South Dakota and Nebraska. In the past, they had been exposed by severe rainstorms, and they were found by Native Americans and considered them the thunder beasts. Which is kind of where it inspired the name, Brontotherium from. But many of these skeletons are actually thought to belong from herds that died during volcanic eruptions of the Rocky Mountains, which were considered active at the time, so they were active volcanoes at the time. There you can see the difference in there. You can see these guys interacting, very, very cute. But yeah, here's the Megacerops. So this Megacerops was done by JWE2. Really, really wonderful job for JWE2, giving us a lovely mammal, and I always do love talking about mammals. So again, we're going to let them run off and do their own thing, and then we're going to talk about another really cool species. Master Dude is back with another cool mod, which is a remake. He loves going back and remaking his mods, but I do always here for it. I do always love to see them. So today we're going to have a look at his updated version of Maip macrothorax. Maip, another really cool guy. See if we can get a nice posture out of one of his. We'll have a look at you. You look nice. I like this one. Probably gives you a great example of its body. Oh, no, we'll go with this one. This is Maip macrothorax, and I like the grey colour of this one. It actually looks quite nice. So Maip is a large genus of Megacerops theropod that comes from the late Cretaceous of the Coelurosauravus Formation in Santa Cruz, Argentina. And it contains a single species, which is known from a disarticulated skeleton. And what makes it kind of notable, it is the largest Megaraptoran known from South America, and potentially the largest one known in the world. So we'll get into that shortly. So Maip holotype was discovered by Alexa Ronaldo in the La Atila farm, 30 kilometers west of El Cafafe in Santa Cruz, and discovered in 2019. The specimen is known from axal, several dorsal and caudal vertebrae, cervical and dorsal ribs, gastralia, a left coracoid, fragmentary scapula, partial right pubis, and a partial metatarsal. And they were first announced in preprint in 2021. However, the paper did not meet the necessary requirements and it was considered informally named. But in 2022, it was validly described as a new species in genus, with the name Maip being with references to a malicious being in Enochic mythology, which is the shadow of death that kills the cold wind. And macrothorax just means big thorax because it has a big chest. So in terms of its description, Maip was thought to have been about 9 to 10 meters long in life, and this would make it one of the largest known Megaraptorids known, because most of them are quite a bit smaller. And members of the Megaraptorids have seemed to have increased in body size from the extinction of Carcharodontosaurs in the southern hemisphere from the early late Cretaceous. So it is hypothesized as they went extinct, the Megaraptorids would have got bigger to occupy this niche. And Megaraptorans, including the Abelisaurs and Unilagines, became the primary predators. Analysis shows of clades in South America, Asia, South America, and Australia range from about 4 to 5 meters during the Brahminian Aptian. And then once they reached Tenorian stages, they would have gotten to about 4, 5 to 6 meters. And then eventually, once you get to the Maastrichtian, forms were larger and getting up to about 6 to 10 meters, which means Maip as well. So pretty much the size of many large, would have been up there in size with things like Tarbosaurus and things like that. In terms of its phylogeny, it has shown to be related to other species of Megaraptorans that are from Argentina, and they seem to have kind of formed two clades, kind of these big Argentinian or South American species of Megaraptorids, and then the clade, which is clade B. Clade A is things that are more basal, things like Fukuya Raptor and Australoveneta, so more basal ones, which is interesting as well. But in terms of where it lived, it is known from the Maastrichtian dated Colorado Formation in southern Argentina. Would have lived with animals such as Incuricursa, which was an elasmotherian ornithopod, something the hadrosaur but not. Nullotitan, which was a titanosaur, but also remains of things like ankylosaurs, Euintelligence, hadrosaurids, noasaurids, and unilagines from this area. And other fossils of smaller animals that would have lived in its habitat include frogs, fish, mammals, mosasaurs, snake, turtles, and gastropods as well. And there is fragmentary remains of another Megaraptorid, which could potentially be Maip or another genera altogether. But we don't know that yet. But yeah, it's still a really cool species, and I always love how Master Duke kind of reconstructs this one, giving it a bit of feathers and this really big arms. It shows, they kind of went the opposite of T-Rex. Instead of having big heads, they had big arms. Yeah, really, really beautiful, and I love the pattern on this one. So yeah, I think this is about time to end the episode. Really, really nice one here. Some really cool species. Thank you, Trip, for making the Paleozoic pack. Amazing pack to talk about those animals. And then we've also got Netraptor and Jojo Chess and Master Duke making those extra wonderful mods for today. Really, really do love it. And nice to be shown in, the penultimate to 100. Hopefully we'll get there before Jurassic World Evolution 3 comes out. But yeah, I really, really, really hope you guys have enjoyed this video. If you guys like and subscribe, always remember to get the little bell icon to get notified of anything. So if you guys enjoyed this video, hope you guys like and subscribe, and bye-bye.